Good morning, guys. Been here for quite a while, only two of you. Wait another 10 minutes before I begin. All right, so there are just 4 of you here. There were 5, 1 just left. They are okay, joining back. 1, 2, 3. There are 5 of you here now, and let me see what is happening here. Good morning, sir. Good morning, everyone. Good morning, guys. Again, for those of you who didn't hear my good morning. 1, 2, 3, 4, 5. All right. I'm waiting another 3 minutes and then we begin. And we are beginning. We're continuing where we left off. Can you just bring up your notes, please? So it is that you're ready for me when I'm in another 3 minutes or so. Thank you. Come on. Okay, where were we the last time again? Anybody remembers? Where were we the last time? Hello? Guys, where were we the last time?
Their exponent.
Thank you. So we looked at Pascal's triangle,
Yes.
and then now we started. Did we actually start the combination notation? Did we look at factorials?
Sir, I'm not sure.
Is there anyone that can confirm? Is there anyone else that can confirm?
Sir? Sir?
All right, guys. So who was calling sir a while ago?
Sir, I was calling you because I'm not hearing anything, so I was wondering what's going on.
No, because Donnie, I asked a question for about half an hour ago. Georgie answered me, and I said, "Can anybody confirm what Georgie says?" And nobody answered me. And to be honest with you, I kind of have no for me head. I'm kind of tired-ish. Me now go. Me now go say. So me just say me go wait until 9 o'clock we'll do it because every Saturday me in the same sort of mood, and Saturday is my day, so me shouldn't have after I hurt up my head. So me do just say 9 o'clock because it is what it is. Me Tajia saw your message. All right. So thanks, Tajia. I just wanted somebody else to confirm what is happening. I'll soon come.
Okay, sir. I wasn't here, so that's why I wasn't here last week, so that's why I never really answered, sir. Because remember that I went and do the police record. Sir? Sir, are you hearing me?
The name same soon come.
Donnie, sorry, go ahead, Donnie. I have to run for something. Go ahead again, Donnie. Sorry. Don? All right. So let us continue. Anybody hear what she was saying?
Yes, sir. I was saying that last week I wasn't here because remember I went and do the police record.
Man.
So I wouldn't.
You did.
Yeah.
No, but Donnie, I'm not talking about you, Donnie. I know you left, but there were so many others in class last week that could have responded. I know you left, Honey Munches. All right.
So, I wasn't here either.
Who is that? Ali?
Yes, sir.
Yeah, but I mean, fine if you weren't here, the other thing you could do is to say, boy, sir, I wasn't here. But when everybody is silent, and I can go silent too. That's the point I was trying to make this morning. So I don't have to come every day and hot up my head. I can also go silent. And when a teacher goes silent, trust me, it's really not a good thing.
I'm trying to remember back in the day, Kevin.
What was that, Donnie? I mean, Ali?
I think so.
Sorry? All right. Okay. All right. So yeah, I refuse to go in there, which would actually be unfair to me. So all right. So let us see if we can continue. I wanted to find out if we had done I know we did Pascals, and I know we finished our Pascals. I know I gave you work on Pascals, but what I wanted to find out was the factorial notation. If we had gone through the factorial notation, let me share something with you, and tell me if you are. Share my screen. Let me share something, and tell me if you are seeing and agreeing with what it is that I have. Did we look at the? By the way, are you seeing the screen?
Yes, sir.
All right, did we do that? The combination notation, permutation and factorial notations?
Oh,
No, sir.
no,
Okay, all right, fine. So that's what I wanted to ask about half an hour ago, just to see exactly where I'm at, because a few of you who joined my class last night, my other class last night, would have recognized that I'm teaching something very similar. This I would have already gone through with them. So when I ask a question, it's not that I don't know or prepared, but sometimes I get confused because I'm teaching pretty much the same thing to two different groups. I don't remember which group I taught it to. So that's why I was just asking just to jog my memory. All right, so we're on to the combination notation, a combination, permutation, and factorial notations. Let us see if we can use the rest of the time today to just finish off this area. I don't have much in this to be done. Let us just see if we can finish off this area. All right, so we have the combination, permutation, and factorial notations. Now, what I want you to do is, before I even go into there, I want you to read through this on the screen. I want you to look at permutation. You may not understand what is happening there, but I want you to search your calculators to see if you can find something on your calculator. But I'm going to tell you, it's a factorial notation, and the factorial notation is an exclamation sign. So you're going to take a couple of minutes, look for the exclamation sign, and you're going to look to see if you can do, for example, what I have in example 2.31, if you can do that calculation from using your factorial notation. I'm going to give you a couple of minutes. I want you to read through, because part of this thing is for you to learn how to read through the stuff on your own. So I'm going to give you about 5 minutes to read through. Then I'm going to come and explain the difference between combination, the difference between permutation. But before I move, I want you to recognize that this part is very important. Whether or not I get you for business statistics or someone else, permutation and combination is going to come up into your business stats. So it is good for you to have the base here now. I won't get into the nitty-gritty of it, but just to explain, in brevity, what exactly it is. So take about 5 minutes and just read through this for me. All right. How do I do this now, Lord? How do I do this? Hold on. All right, so do you see what is happening right there? The factorial notation is saying, n factorial is going to be n times n minus 1 times n minus 2 times n minus 3 times n minus 4. In other words, if I ask you to evaluate 5 factorial, it's going to be 5 times 4 times 3 times 2 times 1. 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What is 2 factorial? 2 times 1. So what I'm doing is multiplying all my numbers in a descending order. So n factorial, when I have n factorial, it's n times n minus 1. It means that I'm subtracting 1 from it. Then I'm going to multiply by subtracting 2 from it. Then I'm going to multiply by subtracting 3 from it until I get down to 1, which is k, until I get down to 1. So the combination notation is saying to us that NCR, look at your calculators now for me to see if you see something that says NCR or NPR. Well, not or, but and. NCR and NPR. Anybody? Somebody?
Yes, sir, I see it.
Good, very good. So that the P is for permutation and the C is for combination. All right. I would have taken you through an exercise, but because we lost some time, I can't do that for you again. All right. But so the combination notation is going to be given as n factorial over n minus r factorial times r factorial. N factorial over n minus r factorial times r factorial. And the permutation is going to be just n factorial over n minus r factorial. All right. So when we look at example 2.3.1 for argument's sake, we're evaluating 5 choose 3. Do me a favor. Take up your calculators, press 5, then press the NCR button, then press 3, and press equal and tell me what you get.
So we get the exact same answer as
As
the
I have been,
example.
very good. And that answer would have been 10. Very good. So that's how we go about evaluating our combinations. That's how we go about evaluating our combinations. But what I want you to do is to look to see how we do it manually, meaning using the calculations method. Using the calculations method. All right. Now, what I want you to do for me now is to try for me 5p3 and see what you get for 5p3. So you just did 5c3. I want you to try 5p3 for me now. Anybody got 5p3? If your p is on the submerged part of the key, you have to press second function or inverse in order to access it.
So 60.
Yeah, 60.
Look at that. You see that there? That's how we get the 60. So what I want you to do is I want you to just recognize those two formulas. NCR formula and the NPR formula. Very important. Very, very important in dealing with the calculations that we have. Very important in dealing with the calculations. All right. Now, All right, what I'm going to ask you to do for me now is not looking at the example. What is on screen here now? Combination. I want you to look at it and look look carefully at it. I want to see if, matter of fact, there are a few of you in class. I want you to look at it, the a plus b raised to the nth power. And I want you to look at all of that I have in pink and blue and tell me, see if you can look at any similarities, what you think. There are about 4 or 5 things that are very similar right there, and some things that I'm going to be pointing out. But I want you to take an opportunity to look at it, to tell me what looks very similar, what you think is always the case because you're seeing it right across in the first 3 things that I wrote, and even the last one, the n through n, you're seeing something that is very common. I want you to take 5 minutes exactly to look at that, to tell me if you see anything similar, because I'm going to be asking different ones of you to answer. All right? So starting now, please. Okay, let us have a conversation now. Let us now have a conversation. So when you look at it, Tajay, tell me what's the first thing that comes to mind when you look at it?
So it look oddly similar to the Pascal triangle where I use
Okay.
with the ascending and descending order.
All right. So very good observation, and you are correct. All right, Georgie. Let's just see who and who are present. I'll connect Georgie, Terry. All right. Kerry B. Tell me what you think that looks very similar to this thing here. Georgie, coordinate, anybody? Alison?
Sir, the same thing that we did last class.
Right, with Pascals. Okay. All right. All right. But let me just go a little further. Let us look at the first two things in pink. The n through 0 times, and that dot is big school now, so that dot don't mean full stop. It means multiplication, eh? So the n through 0 dot a to the n dot b to the 0. It means that n through 0 times a to the n times b to the 0. So what is a to the n and b to the 0? Remember, we're talking about a binomial. So we're talking about two things. And let us look to the far left. We have a plus b to the n, a plus b to the n. Binomials, there are two terms in my parentheses. Always be two terms in my parentheses. All right? So watch what happens. You remember the last time I said to you that when we're doing Pascals that we're going to use the first term in the parentheses and raise to the highest power. Anybody remember that?
Yes, sir.
Right. It's the same thing that we're doing here. Look at the a to the n. The a is raised to the n, which is the highest power. But because we're using a combination notation now, look at what is happening. We are saying n through 0. We have to start at n through 0. We're saying n through 0, a to the n. But remember, when one descends, the other one ascends. One must descend first before the other one can ascend. One of them must descend first before the other one can ascend. In other words, one of them must give up something first before the other one can accept it. That's what I'm saying. One of them must give it up first before the other one can accept it. All right? So this is what is happening. One of them must give up first before the other one can accept. So this is n through 0, a to the n, b to the 0. Oh, but sir, you know, the we also said last class that the sum of the overall powers is supposed to be equals the same. N plus 0 as the powers is equal to the overall power n. All right? But look at this also. We have plus n choose 1. Oh, so we're counting up because since we started n choose 0, we now reach at n choose 1. Very good. So we now have n choose 1 and n choose 1, and then we can have a to the n minus 1. Yes, sir. I remember that because they always said to us that you're subtracting 1 from the power. Very good if you can remember that. Very good if you can remember that. We're subtracting 1 from the power all the time. All right? And then now b is going to be accepting that 1 power that a loses. B is going to accept that 1 power that a loses. All right? And so forth and so on. Now, based on what I just said to you a while ago, I want you to use 2 minutes to just look at that pattern, look at that sequence. If you understand this sequence, everything that I'm going to be doing thereafter will be easy. It's like butter in the sun, melts very quickly. So take 2 minutes just to look at what it is that I talk about right there and see if you can see the resemblance. Yes, all of you are correct. It's very, very, very similar to Pascal's, extremely similar to Pascal's. All right, take 2 minutes and do that for me, please. Look at the pattern with the a, n minus 2, and the b to the second power, n minus 3 and b to the first power. I want you to see all that pattern taking place in that sequence that is going on right here. Two more minutes. Yeah. What I want you to look at the subscript. Now the subscript is what you write at the bottom. Look at the subscript of all of them and see if it matches with any of the numbers as a superscript in any one of them. That's a hint. Look at the subscript of the C's to see if it matches with anything as a superscript in any of the other terms. Take 2 minutes to look at that. You see any significance between the subscript of the C and the superscript of any of the A or B? If so, tell me what is seen. Nobody not seen anything? Look at it again, man. Look again, look.
So the subscript is the number or the letter before the C or the one below the C.
The subscript is going to be the one below the C, like N through 0. 0 is a subscript. And
Okay,
N
so
through
sir, so for the similarities that it's the one that is raised to the A and the B.
You sure it's to the A or it's to the B?
To the B.
Okay, to the B. Everybody look at that. Very good, Donnie. Everybody
Yes,
look at
sir.
that. Does anyone agree with what Donnie is saying? You notice where what I have in pink, the 0 is a subscript in the C, but the 0 is a power in B. That is going to be very important, what I'm showing you. If you look at N choose 2, that 2 as a subscript and the 2 as a B squared is going to be very important. So those are some of the things that you need to look at. And then look at what happens. Let us look at the N choose 2. All of you look at the N choose 2. We will have N choose 2 times A to the N minus 2 times B squared. Do you recognize when you add N minus 2 plus 2, you get N? Talk to me.
So go again with that one. N minus 2 gear N.
N minus 2 plus 2, what does that give you?
N minus 2 plus 2 over gear N. The answer will be N because it will cancel out.
Okay, fair enough. What is N? What is N minus 3 plus 3?
N minus. Repeat, sir. Repeat that one.
N minus 3 plus 3.
Sir, is the same as N?
Yeah.
Very good.
So I
Cancellation.
thought you said another 3. That's why me and say you never did that click. But okay.
So you see what is happening? All of those will be equal to our overall power N. All of those will be equal to our overall power N. All right, do me a favor. Before I even go through example 2.24, 2.21, 2.41, I'm sorry. I want you to look at it to see if any of the similarities that we spoke about just now is present in that one. I give you 3 minutes thereabout to look at that, and then I'm going to come and go through the question with you.
Are we not? Oh.
All right, now let us look back at it. So the question says, use a combination notation to evaluate 2x plus 3 raised to the third power in ascending powers of x. But remember, as per Pascal's, we're not even going to pay the ascending or descending powers of x until we're finished doing stuff. Finished doing stuff, then we just fix it up. We put on the gravy on the right. All right. So it says use a combination notation to evaluate 2x plus 3 raised to the third power. Look at what is happening. Look at what is happening. I'm going to say 3 through 0. So how you get 3 choose 0? Remember, we always start at 0. So it's going to be 3 choose 0. And then we're going to times the 2x to the highest power, which is to the third power. And then that 3 is going to be raised to the 0 power. So why? You remember, because A has not yet descended for B to ascend. So that means 3 can't get any number yet. But besides, the subscript in C says that it is 0. That means the superscript in B must also be 0. You see that? You see that correlation?
Yes, sir.
All right. Somebody else go see. Look at it. Look at it. I want somebody else to look at it and agree with me. The subscript in C is the same thing as the superscript in B. Look. Somebody talk to me now. Tashi answer, but I want to know the rest of the C. All right, let's go. So, and then now I'm going to move on to my second term. So I'm going to say now 3 choose 1. So why 3 choose 1? Because the first one was 3 choose 0. So we now reach at 3 choose 1. Remember, since 2x was raised to the third power, it is now going to be raised to the second power. So we have 2x to the second power and b to the first, which is why Tajay said search oddly similar to Pascal's. And it is. It is. So now remember the subscript in C1 now becomes a superscript in B, which is 3 to the first, and so forth and so on. Now, what I want you to agree with me, to take up your calculators now and work out that recall 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, and tell me if you agree with the 1, 3, 3, 1 that I have there.
Yes, sir. I worked it out. It's correct.
So you figure that part out, all right? So what is that similar to, Tajay? Tell me what that reminds you of.
One, three. It reminds me of the third power when they no the third power when you're using the Pascal triangle.
Very good, Taj. Excellent. Very good. Very good. Very, very good. Excellent. Now, look to see if you now can evaluate that first line that we have after answer, example 2.41, that first line. See if you can evaluate it for me, please, to get the line after the note. See if you can use your calculators and your brain space and just evaluate that. Very nice. Everybody okay? So the 3 through 0 is going to be 1. I put that in red. And 2x raised to the third power is going to work out to become 8x cubed. And the 3 to the 0 is going to work out to be 1. And of course, the 3 choose 1 is going to work out to be 3. So I put the plus sign and then the 3. And then the 2x all squares is going to become 4x squares. And the 3 to the first power becomes 3. Then I put the plus sign. 3 choose 2 is again 3. And 2 to the first is 2. Sorry, 2x to the first is 2x. And 3 squares is 9. So I have it that 3x times 9 there. And then I put my plus sign. And 3 choose 3 is 1. And then 2x to the 0 is also 1. And 3 to the third power is 27. And when I evaluate that, I'm going to get 8x cubed plus 36x squared plus 54x plus 27. Same thing as you would have gotten for Pascal's. Then, sir, why did we have to learn this method? Okay, thank you for asking. It's important because Pascal's, as I told you, has its limitation. If I wanted to find the fifth term of Pascal's, I have to know what the fourth term is. And in order to know what the fourth term is, I have to know what the third term is. And in order to know what the third term is, I have to know what the second term is. And in order to know what the second term is, I have to know what the first term is. That's the limitation to Pascal's. But for the combination notation, I can find any term that I want without knowing the previous term. Sir, how do you know that? Okay, watch me. Let us look at our answer, 8x cubed plus 36x squared plus 54x. If I say to you, write down the term in x, write down the term in x in the expansion of 2x plus 3 to the third power. Remember, you know, the question said we must write down the term in x. So in my binomial, my a and b, I'm going to look for the term in x. And it said we want the term in x. It never said x to the second power, x to the third power, x to the fourth power. It says x, meaning x to the first power. So what, based on what the question says, I must raise my 2x to the first. That's what the question is saying. And if I raise my 2x to the first, it means that my 3 must be raised to the second power. And if my 3 is raised to the second power, it means that I'm going to have 3 choose 2. Because remember, the last power and the subscript of the C is supposed to be the same. Now look at the second to last term in the combination notation and see if that's exactly what I just said a while ago. Hello, somebody? You're gone silent again, class.
Yes, sir. Because I was just about to ask why it couldn't be done in Pascal. The way I did it in Pascal last week, but I just explained it.
Very good. So that's why I had to teach you combination, because Pascal's has its downfall. You know, put it this way. You may have, you have 2 pots at home. You live alone and you have only 2 pots, a Dutch pot and another pot. But when what people that call them food pot or them soup pot or them rice pot, you wouldn't necessarily fry chicken in the soup pot or the food pot. You wouldn't. But can it be fried in it? Yeah, but it just now go. No. Why we decide say we're not gonna fry one egg in our dumpling pot or a rice pot, but we're gonna fry it in our frying pan. Why do we do that? Right? So point is, there are several methods. Not that the method won't be right, because yes, I can use this method, Taj, to find the term in x, but it's going to take me a long while. And what if they give me a number that I don't even know the coefficients for? And you'll see what I'm talking about a little later on in this class. All right. This is the true, okay, and it did say in ascending powers of x, so we have to go flip it. You recognize we have to flip it because it did say in ascending powers of x. You see that?
Yes, sir.
So we have to flip it and put the 27 first and the 54x after, and so forth and so on. All right. Now, as a true test, I have example 2.42 that you are going to do on your own. And I'm leaving 2.41 up top so that it can guide you in answering 2.42 for me. So start for me, please. I give you 5 minutes, no more than 5 minutes. How is it going? Are we okay?
Yes, sir. I'm almost finished working it out.
All right, good job. What about the others? Colin, Donnie, Kerry, Georgie, Allison.
Sir, I'm done.
Okay, so you get an answer?
Yes, sir.
Okay, all right. Taj is saying almost finished. I'm going to give Taj 1 more minute. 1 more minute, Taj. One dege minute you have. All right, all right. Here goes the reveal. Did you get that as your answer?
Yes, sir.
Good job. Danny, Georgia Porgy, Ali, Colin, the rest of you.
Yes, sir, but mine is the opposite.
All right, remember the question did say to you in ascending powers of x.
Yes, sir, that me do.
So, so if you put yours in the opposite, if the question carries 6 marks, you get only 5. So we can take 1 mark from not following the instructions. So you have to make sure that how them ask you the question is how you give them the answer. You have to make sure that how them ask you the question is how you give them the answer. Very good. Now, for those of you who are still working on that one, continue working. For those of you who finish and get that answer correctly, look at 2.43. There is another question on board for you to do. Watch me now. Danny, Georgie, the rest of you. This one says descending powers of x. Descending powers of x. So I'm going to give you another 5 minutes. Those of you who are still working, you can look at my solution to look at the error you made. If you didn't make any error, move on to that one. I've given you 5 minutes. Always Steve. Talk to me. Are we finished?
Almost done.
All right, cool. Always Steve.
So I got 243 x to the power 5 minus 810 x to the power 4 plus 1080 x to the power third minus 720 x to the power 2 plus 240 x minus 32.
If I never tell you before, Tarish, thank you. I feel like my class today is worth coming to. Excellent. I'm very, very proud of you. Very proud of you. Very proud of you. Um, and I'm speaking to you directly, no Taj. I'm going to see how well you understand this question by looking at 2.4.4. I want you to write down for me determine x to the fourth in that expansion. While the others work on 2.43, I'll leave the answer there for 2.43 so the others can see. But Taj, I want you to move on to 2.44. And you don't have an expansion for Pascals up to the 12th power. So you now have to use a combination notation, which is a point I was going to make to you, Taj, which is a question you were going to ask me. So let me see how well you do at this, Papa. Please, let today be end up to be a fabulous day. I'll give you a couple minutes, and the rest of you look at number 2.43. And if you're finished with when you're finished with 2.43, guys, I want you to move on to the same challenge that I'm giving Taj, 2.44. Or we stay. Finish it, Taj?
Oh, sir, I'm just about finished.
All right, good job. How about the rest of you? Were you able to attempt that one? All right, no response. Never mind. All right, I'll give you 2 more minutes, Taj.
Sir? Sir? Sir?
There, man. Couldn't unmute. Osh, walk on.
Sir, I was just telling you that I'm going to leave the class, sir, because I'm actually on the road and my battery is at 24.
All right, no problem, honey bunches. You understanding what is happening though, right?
Repeat, sir?
You understand what is happening in the class?
Yes, sir. Sir, you're going to send the document that you were screen sharing in the group, right? I call it.
As usual, man.
All right, sir. No problem.
All right, cool. All right, what good? Charles, you finish your question now, Charles?
Yes, sir.
What you got for the answer?
It's 14.
Talk to me.
But, yeah. For the first, sir, when it said write down determine export in the expansion of 5 minus 12x to the 12th power, I got four. Well, for 12C4, I got 495. 390, 390,625, 16x to the fourth power.
All right, very good. So Taj, let me ask you a question now, Papa. I'm gonna buy a bottle of Pepsi, you know, because I'm proud of you. So remember, whenever you see me on campus, if you know what I look like, just see me and say, sir, you promised me a bottle of Pepsi. So why you never multiply the 495 by the 396.25 minus 16 to get a big number? You're correct, you know. That's what you have. What I have in blue is what you have done.
Yes, sir.
Yeah, man. So multiply out everything and get a big number there. All right, very good. So look at what Taj, I am 110% proud of you. And it's because it's you alone giving me energy in the class today. I'm really proud of you. I'm going to buy the back of Pepsi. Really proud of you, Taj. So do me a favor now. What I have done is to write 4 little sequence that I want each of you now to read on your own and to see if you could arrive at the same answer that Taj just came up with. Very nice.
Sir? Sir, if you're sharing screen, I'm not seeing it.
Oh, sir, that's the exact answer I got. But the reason why I didn't multiply it all together is because the sum would have been too big, and I guess I thought I did the wrong calculation.
Tajay, why you still just like the other students? I had a calculus class this week and I had the same conversation with them. Sir, we never write down the answer because we think the answer is too big. Write it down, man. Write it down, man, write it down. But my brother is still go, write it down. All right, sorry that I wasn't sharing screen. I didn't recognize. Thanks for bringing it to my attention. Go ahead and read through the sequence now for me, the rest of you, to make sure that you're understanding what is happening, because this is the end of this topic, you know. The end of this topic, and I have maybe like about 1 or 2 more examples to give you, and then I'll see if I have enough time, but I have enough time to introduce something else. So take some minutes and just look at that. Very good, Taj. Very, very, very good. Read the sequence for me now, please.
They're not sharing the screen, sir.
How we stay? Hello guys, how are we? Hello.
Oh, I'm good, sir.
Okay. All right. So how we feel with re this topic? How we feel regarding this topic? All right. I have I have one final one here for you. At 11 o'clock, we can start a new topic. So those of you who are hearing me, can you just do 2.45 for me, please? 2.45 and then yeah, 2.45 for me, please. Those of you who are hearing me, 2.45 for me. Anybody finished? Anyone finished?
Oh, almost there.
of them must have done that by now. Hello?
Yes, sir. When you mean the coefficient, I mean 12C0, 12C1, 12C2, 12C3.
Aha. I'm happy that you asked the question. What do I mean by coefficient? What does coefficient mean?
The number. I'm
The
saying the
number
number.
what? The number where? The number in front of. So you notice the first one asks for the term. Remember the first one asked for the term, and he gave me both coefficient and the variable. Coefficient is everything in front of x, or x squared, or x cubed.
Oh.
All right with that now?
Yes, sir.
I got negative 448. What you got?
Yes, sir. I got the same thing.
Right. So the term, so here now, the term is going to be negative 448 x squared, x cubed. That's a term. So you have to know the difference now between the term and the coefficient. So the term is negative 448 x cubed. And the coefficient is now only negative 448. You got me?
Yes, sir.
All right. Now, so in writing your answers, please note that the coefficient refers to the number in front of the variable, while the term refers to both coefficient and variable. Very important. All of the important questions you were asking me today, Taj. Very nice. So the term refers to both the coefficient and variable, and the coefficient only refers to the number in front of the variable. All right. All right, I want you to write the term in for this one, and this is the final one. I want you to write the term in x squared. Write the term in x squared for this one for me, please. The term in x squared. So I want you to write the term in x squared for this one. Quickly, quickly, quickly. 1 minute. The term in x squared. Ready? What do you get for the term in x squared?
Sir, for the one I just did.
No man, so I put another one there now.
Oh, 4 minus 3.
Yeah, 4 minus 3x raised to the third power. I want you to write the term in x squared for me. Ready? Waiting on you, know. Hello, somebody.
Oh, sir, I got a large number.
You got a large number. What is a large number?
622,854,144.
Very good. See it on the screen there. Very good. Excellent. And then I did say that was a final one, and then I could give you another one to say, you know, to the sixth power. So you get the gist of it. So my question to you now, as I move on from this topic into another topic, my question to you is, can you see the significance now of the combination notation?
Yes, sir.
Because I don't even know, the most I can tell you, the coefficients for 12 will be 112. We know the first two, 112, and the last two, 12, 1. And we're not going to sit down and write out all of them something there. So we have to know the combination notation. The combination notation makes life so much easier. Now, the question is, sir, can we always use a combination and don't use Pascals? Yeah, except that sometimes the question will say, by using Pascals, it means that you have to use Pascals because them tell you by using Pascals. Or sometimes the question come and say, by using the combination. Say no, so you have to use a combination notation. But sometimes the question say, expand, and them give the binomial and don't tell you not about no Pascals or a combination. So which one you use? Anyone you want to use. If you want to use Pascals, you use Pascals. If you want to use combination, you use combination. They will not ask you to expand anything greater than 5. They can give you something like 4x minus 3 to the 5th power. They won't give you anything greater than 5. However, they will give you a question like what I have on the screen. Write, expand that, and write the 4th term and then something there. They don't expect you to use Pascals for that. They expect you to use combination like what we have been doing now. So that's what that is. There's nothing more to that than what it is that we're doing here. All right, it's now 11:15. I'm going to give you a 5 minutes break. And then at 20 past 11, we're going to start Kramer's. At 20 past 11, we're going to start Kramer's. I'm starting Kramer's because that's what I'm doing my CAPE class, and I invited some students this week. Some came on Monday, some came on Friday, last night. So I'm going to start Kramer's. Kramer's is not bad, not long. So by next week, we should be finished off with Kramer's. And then come January now, we just have AP, GP, graphs, coordinate geometry to finish off the syllabus. All right. So 20 past, another 4 more minutes. All right. So, so we're on to Kramer's, and Kramer's speaks of um, matrices. Kramer speaks of matrices, and we know what a matrix is. Well, hopefully we remember. We need to know how to calculate the determinants of a 2 by 2 matrix. We also need to know how to calculate the determinant of a 3 by 3 matrix. So what I'm going to be doing today, hopefully, I will be able to use this time, that is a lot of matrix, and determinants of a 3 by 3 matrix, and then we'll call it a day until we meet for final class for this season on Saturday, where we should wrap up Primers. Wrapping up Primers. Come January, I will not be going through Primers again. I'm going to be wrapping up Primers at that point in time. So I'm trying to get the document here for you. Come on, I thought you were open. All right, so let me see if I can share screen. Stop share here. And let me go here in order to get it for you. Oh, hold on a minute here, guys. I don't know what seems to be the problem with this. Oh, come on, not all the time. Sure. Be able to teach her, like, open the documents, man. Sure. When I speak of a 2 by 2 matrix, how can you describe it to me? When I speak of a 2 by 2 matrix versus a 2 by 1 matrix. When I speak of a 2 by 2 matrix versus a 2 by 1, how would you differentiate the two? What can you say to me about it?
One has 2 rows, 2 columns, while the 2 by 1 would have 2 rows, 1 column.
Ah, very good. Very good. Very good. Okay, and a 3 by 3?
3 rows and 3 columns.
3 rows and 3 columns. Which one go from left to right versus which one go from top to bottom?
What's the repeat?
Which one of them go from left to right? Which one of them go from top to bottom? Which one of them move from left to right? Which one of them move from top to bottom? You said rows and columns. Where does a row move? Top to bottom or left to right?
Oh, left to right, while column would move from top to bottom.
Very good. All right. Very nice. So one move left to right, one move top to bottom. All right. So let me share this screen with you now. Let me share this screen with you. And you will, oh Lord. So if you notice here, it says naming of matrices. We're talking about rows. They are horizontal from left to right, and columns are vertical from top to bottom, right? So for matrices, matrix is singular, matrices is plural. So when I speak of a matrix, I'm speaking of one. When I speak of matrices, I'm speaking of more than one. So for example, I have A11, A21 as shown there. That one is known as a 2 by 1 rectangular matrix. Why is it known as a rectangular matrix? Why is it known as a rectangular matrix?
Well, sir, it looks like a rectangle and the length and width isn't equal.
Say it again.
Oh, sir, I said it looks much like a rectangle and the length and width of the matrix isn't equal. Like
Very good.
question 4.
Excellent. Excellent. You're on a roll today, Taj. Very nice. So the row is not equal to the column, so that's why it's called rectangular. All right, so that's the reason. The row is not equal to column, so it's rectangular. Even if it has 2 rows and 1 column, so they're not equal, so it's rectangular. Let us look at the A11, A12 in the second example. You agree that's a 1 by 2 matrix?
Yes, sir.
Because you call the rows first and the columns after. So it's a 1 by 2 matrix. And of course, that too is rectangular because the number of rows ain't equal to the number of columns. Now let us look at the third example. A11, A12, A21, A22. That's a 2 by 2 matrix down.
Yes, sir.
And is that a square matrix?
Yes, sir. 2 rows and 2 columns.
Very good, because the number of rows equal the number of columns. So you see your geometry is coming into play right here. Your geometry is coming into play right here. So the number of rows equal the number of columns, so it's a 2 by 2 square matrix. Similarly, the A11, A12, A13, A21, A22, A23, A31, A32, A33, that is a 3 by 3 square matrix. Again, the number of rows equal the number of columns. Now, can anybody me is it because of A1, A2, A2, what's the significance of that? Tell me. What do you think? What do you think? Don't what am I talking about? Talk to me now.
Oh, sir, can you repeat?
And I'm saying to you, what do you think the significance of the A11, A12, A21, A22? What do you think those mean? Nobody? Just hazard a guess, no? Is that right or wrong, you know?
Said
Sir, first row, first column.
Very good. So A1 first. So what A2 saying? Hmm?
Sir, A21 is second row, first column.
Second row, first column, right? So the significance of this is that the rows are called first and then the columns called after, right? A21, A22, A23, A31, A32, A33, they're called elements or entries. They're called elements or entries. Each element or each entry has a specific position in a matrix. Each element or each entry has a specific position in a matrix. So I cannot take the A11 and put it in the A22 position and feel comfortable. Each element has a specific position in a matrix. All right. So you just need to remember that. All right. Now, there's another conversation that I want us to have. It's very important, a very important conversation. And this is it. It says for this course, we are concerned with a 3x3 matrix. For this course, we are concerned with a 3x3 matrix, predominantly, because we're going to end up using a 2x2 matrix too, in order to solve the 3x3. We're going to use a 2x2. We're going to use enough 2x2. So for every 3x3 matrix to do, we're going to use several 2x2 matrices. Watch me. On A22, A23, A31, A32, A33, 3x3 matrix as indicated there. And again, I'm reminding you that we call the rows first, followed by the columns after. And I'm saying to you that A11 indicates the elements in the first row, or indicate the element in the first row and the first column, and so forth and so on. So I'm saying to you now, please note that we speak of the ith row and the jth column. So the rows we signify as I, and the columns we signify as J. So we speak of the ith row and the jth column. The ith row and the jth column. So what's the significance of the ith row and the jth column? Well, thanks for asking. It is important because if you look carefully, you'll see -1 raised to the I plus J. So what it means is that I'm going to be adding my rows and my columns. I'm going to be adding my rows and my columns. Now, if you look carefully, you will see A11, A12, A21, A22, A23, A33, and so forth and so on. Now, look at this magic. You see, when I have -1 raised to the 1, the 1, 2, the 1, 3, the 2, 1, the 2, 2, the 2, 3, the 3, 1, the 3, 2, the 3, 3. Look at what it results in. It results in the first one, A11, it results in a +1, then a -1, then 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 a +1. Please note that when you have a negative number raised to a positive power, the result is always positive. And when you have a negative number raised to an odd power, your result is going to be negative. So when I have a negative number raised to an even power, it is going to be positive. When I have an odd number and a negative number raised to an odd power, the result is going to be negative. So this is going to give birth to what we call the array of signs. It gives birth to what we call the array of signs. And it's, look at it again up top. It says +1. We're not really concerned about the 1. What we're concerned about is a positive, then the negative, then the positive, then the negative, then the positive, then the negative, then another positive, another negative, and another positive, right? So normally when we speak of the array of signs, we speak of the plus, minus, plus, minus, plus, minus, plus, minus, plus. That array of signs is extremely critical in solving a matrix question using Cramer's. plus, minus, plus, minus, plus, minus, plus, minus, plus. Very important ingredient in the application of Kramer's. You can't get rid of it. Can't get rid of it. All right. So with that said, are there any questions? Any questions?
No, sir.
All right. With that said, I want you to look at something for me. I want you to look at something for me. I want you to look at all of that and see if you can see how I arrived at it. I give you 2 minutes to do that for me. All right. That's enough time to look at that. So you recognize I have a system of linear equations. I have a system of linear equations. 2x plus 3y plus 4z equals 12. That's equation 1. X minus 2y plus z is equal to negative 2. That's my equation 2. And x minus y minus z equals negative 2. That's my equation 3. So I'm going to write the system of linear equations in a matrix form. I'm writing the system of linear equations in a matrix form. Now, very important. Please note that we are looking at the coefficients of the variable. We are looking at the coefficient of the variable. We are looking at the coefficient of the variable, right? And the variable coefficient, again, remember, it's going to be the number in front of the variable. We learned that we're reminded about that just now. Right? It's going to be the number in front of the variable. Very, very important. So if you look at the equations, all I'm taking are just the coefficients. That's all I'm taking, just the coefficients. I'm not interested in any of the x, y, and z just yet, just the coefficients, all right? Just the coefficients. Now watch me. So if you agree, let us look at all the x's from equations 1 to 3. You recognize that the number in front of the first equation in front of x is 2. The number in front of the x in the second and third equations are 1. Both of them is equal to 1. So we have 2, 1, 1 in my x position. Let us look at in the y position. Let us look at the y position. In the y position, I'm going to have 3, negative 2, negative 1. I'm going to have 3, negative 2, negative 1. 3, negative 2, negative 1. In that column, I'm going to have 3, negative 2, negative 1. All right? That's what I'm going to have in that column. 3, negative 2, negative 1. Very important. Then, in the other column now, let us look at, for argument's sake, the value of z. Z is going to be 4, 1, negative 1. Look in the matrix to see if I have 4, 1, negative 1. Yes, I do. 4, 1, negative 1. So I'm going to write now my x, my y, and my z. I'm writing my x, my y, and my z. And then, of course, that is going to be equal to what the matrices were equal to. Also, what the matrices were equal to, which is 12, negative 2, augmented matrix. What I have there is an augmented matrix. So what do you mean by augmented? It means somebody just separate the matrix them. Separate the matrix them in different stuff. The 3 by 3 by itself, the x, y, z, and then what is equals to the 1, 2, 3. That's all I'm doing, right? Very important, very, very important. So that's the first step. Are there any questions regarding my first step in solving my stuff? Any questions? Any questions? Talk to me now. Any questions?
Yes, sir.
Okay. Then now, I am moving into the other step. What is the other step, sir? The other step is to now apply my array of signs. The other step is now to apply my array of signs. Oh, sir, that is a plus, minus, plus, minus, plus, minus, plus that you had done. Yes. So we have to show them how we get the plus, minus, plus, minus, plus, minus, plus? No. We just know, say we have the array of signs and we're going to use it. Right? So I'm just applying the array of signs now. So look at what happens. Let me pull this on a little bit. When you look at the matrix up top, the 2, 3, 4, 1, negative 2, 1, 1, negative 1, 1, and you look at the bottom, all I have done differently is just to put the plus, minus, plus, minus, plus, minus, plus, minus, plus over each element in the 3 by 3 matrix. Take a minute and look at that for me, please. and agree with me? Hello? Hello, somebody?
Also repeat.
Hmm?
I'm sorry, could you repeat what you said?
And I'm saying to you, when I look at the matrix, the 2, 3, 4, 1, negative 2, 1, all I'm doing there is just to put the array of signs in. So when you look at that, the three matrices up top compared to the three matrices at the bottom of this page here, all that is different is just me putting in the plus, minus, plus, minus, plus, minus, plus in the stuff. Do you agree with that?
Yes, sir.
All right, that's all I'm doing. Now is when I'm going to calculate the overall determinant. So you see, look at that line. 2 with the plus up top, 3 with the minus up top, 4 with the plus up top, so forth and so on. I'm writing that right there. I'm writing that right there. Now, what I want you to do for me now is to write down that matrix. The 2, the 3, the 4, the negative 2, 1, 1, negative 1, negative 1. I want you to write that in pen in your notebook for me. You're going to write that in pen in your notebook for me, please. Let me know when you're finished writing it. Hello? Sure.
Yes, sir, we'll finish.
I'm going to write it. All right. Now, watch me. I'm using, you notice that I'm using the flow. And I did say, remember, no diagonals. So about the remember no diagonals part. We're using the first row. What's the first element in the first row? Hello, somebody? Why don't you respond to me when I ask that question, guys? Jeez,
2.
2. All right, so do me a favor. 2 is the first element in the first row. Very good. Do me a favor. I want you to use a pencil now to draw a line to cross out all the elements in the row where the 2 appears and cross out all the elements in the column where the 2 appears.
Yes, sir.
Write down the matrix that is left. You're supposed to have a 2 by 2 matrix that is left. Write it down for me, please. Then tell me what it is. Do you agree that you have negative 2, 1, negative 1, and negative 1 left?
Yes, sir.
All right, very good. Use an eraser now to erase the mark that you just made for me. Use an eraser to erase the marks that you just made for me, please.
Finish, sir.
All right. Do it for me now. All right, so we're now using the sign. So So you have, look at what I have on paper. You notice I have -3 because the array of signs only affect the cofactors. And the 2 and the 3 and the 4, those numbers that are colored are termed as my cofactors. All right. So now the next cofactor is going to be -3 because it takes now into consideration the array of signs. So I'm now writing -3, -3. All right. And I'm going to ask you again to do the same thing you did before. Whichever row or column the 3 appears in, you're going to use a pencil to cross it out and tell me if you agree with what it is that I have on paper.
Yes, sir.
Okay, very good. And then the other cofactor is going to be +4. Then, sir, what if there was a -3 right there? So, and the number up top, there is negative. Good question. Then I'm going to have a +3 as my cofactor because those two negative numbers will be multiplied together. All right. And you see examples with those. The next cofactor is going to be +4. Next cofactor is going to be +4. So you can write down a +4, and then you're going to do the same thing again. Use a pencil or erase what it is that you have on paper. Then we can use a pencil now and mark out the column and the row that that +4 appears in and see if you agree with me.
Yes, sir.
Okay, I heard that. Yes, very good. Please note that the array of signs only affect the cofactors. Agree with me. Did any of the plus, minus, plus, minus, plus, minus, plus went into the newly formed 2x2 matrices? Hello?
Yes, sir. For the
Say no.
-3.
No, man, say no. So the plus minus plus minus plus minus plus did not, I did not utilize those into the 2x2 matrices. They were only utilized in the cofactor.
Oh,
Can you see that?
yes, sir. I see that. The -3
Okay.
I was talking.
Okay, all right, good now. All right, okay. So now what it is that we're going to be doing, I'm going to recall for you how it is that we evaluate the determinant of a 2x2 matrix. So to evaluate the determinant of a 2x2 matrix, what it is that we're doing, we are saying the leading diagonal minus the other diagonal. The leading diagonal minus the other diagonal. So watch me. Take note of the matrices that you just wrote. The 2 times the -2, -2, +1, -1, -1, the -3, 1, 1, 1, -1, the 4, 1, -2, 1, -1. And let us see now how it is that we're going to be calculating the determinant of those matrices. Remember, it's the leading diagonal minus the other diagonal. It is the leading diagonal minus the other diagonal. So what I'm going to be doing is to multiply that leading diagonal with the -2, that leading diagonal with the -2, that -2 times this -1 is going to give me this value right under here. That's the -2 times the -1. That's the leading diagonal, and that's what that gives me. That's what that gives me. Watch me now. Minus, which is in pink right here, the other diagonal. That's where I get this 1 now. times this -1, which is right here. All right? That -3 is right there. Then again, no, I'm going to say the leading diagonal minus the upper diagonal is going to be that, going to be this one times this -1, which gives me that. Minus is always a minus inside. That's why I have them colored for this example. It's always a minus sign that is inside there. Every single time, barring none, always a minus sign. And then I'm going to have this one times this one. And this is it. That's the 1 times the 1. So you have a minus there. No, the minus comes from the minus sign that is right up here, so in the middle, right up in here. So, all right. And then this +4 is this +4 right here. And then this is going to be 1. 1 times -1 to give me this 1 times -1 right here. Minus, always a minus sign that is in between. That's why I color it pink. That -2, so I put it in parentheses, times that 1, which is right there. So that's how I calculate the determinant of a 2x2 matrix. That's how I calculate the determinant of a 2x2 matrix. All right? And then now, we evaluate it. That -2 times -1 will give me a +2. See it right there, so? That one right there, so. And this -1 times that -1 will give me a +1. See it right there, so. And then this -3 is right there. And then I'm going to have -1 times +1 is a -1. See it right there, so. And then we also have another -1 times a +1. Give me a -1. See it right there, so. Then that +4 is that +4 there. And then this -1 times +1 gives me that -1 right there. And this -2 times that 1 gives me a -2 times this negative here gives me a +2. See it right there, so. And then now I'm going to have 2 plus 1 gives me that 3. -1 minus 1 gives me -2. And -1 plus 2 gives me +1. Then I'm going to say 2 times 3 gives me that 6. -3 times 2 gives me a +6. And 4 times 1 gives me a +4. Now, 6 plus 4 plus 6, 6 plus 4 plus 6 is 16. So the overall determinant is going to be 16. The overall determinant is going to be 16. Do you think you have seen what it is that I have done right there? That's me showing you how to calculate the determinant, you know. To be honest with you, Kramer's almost finished. There's one other thing, 2 other things that I need to show you. And I'm not going to show you today. 2 other things that I need to show you that I won't show you today. But before we close, do you see how it is that I calculate the determinant a while ago of the 3x3 matrix? I reduced it to 3 2x2 matrices and then calculate the determinant of those 3x3, the 2x2 matrices, evaluated until I arrive at my answer 16. Any questions? If not, thank you for turning out. Next week, Saturday, is our final class for this leg of the semester. Remember, the semester continues into January. I think we're going to be having 3 more classes in January. That should afford me more than enough time to complete the 3 topics that are left. So have a good one and be safe. Please study.
Yes, sir.